squares, okay? So for day 4, we're going over rectangles and squares. So we're going to start with rectangles first, okay? So an easy way to get rectangles is that if you have a rectangle, what do we know about a rectangle compared to just a regular parallelogram? What do you think? Sally? What does that mean? Oh, gotcha. Can anyone else help us out? What do rectangles have that not all shapes have? Yes, we have right angles. So what we're going to do by using the slopes, okay, to show it's a rectangle, I think the easiest way to do it is to show that we have all right angles or all 90-degree angles. Now, this is a little bit tricky because remember, on a graph, what we really need to show is that the sides that connect to each other have what kind of slopes? Perpendicular, which means they have to be opposite reciprocal slopes, okay? And these are for the sides that are called consecutive. You could use the word adjacent here if you want to, okay? The ones that are next to each other. So if I graph, right, K, which is 0, 4, and L, which is 4, 2, okay, this line, when I connect to M, which is 1, negative 4, these two lines here are supposed to make a right angle, okay? So just keep that in mind that when you do KLM, the KL and LM should make 90 degrees. Okay, LM and negative 3, negative 2. MN should make 90 degrees, and then the same thing with MN and KL going around, or NK going around in a circle here. All right? So, what can we do to show our work to find the slopes? Or if we're going to state the slope, right, of KL, all I have to do is count the rise over run. Now remember, we previously drew in the little right triangle for ourselves. Do you have to draw this in though? No, you just have to state what it is. So if you notice, we're going to go up to left 4. That means we have a slope of 2 over negative 4, which is negative 1/2. Now, keep this in mind, that before I even do the slope of LM, I should already know what the answer is going to be, correct? If this is negative 1/2, mine should be 2. Perfect. So keep in mind that we should already know what it is. So if I draw my line in, notice that we're going over 4 and up 2, 4. Wait, it's not 4. It's 3 and up 6. So it's rise over run, right and up. So positive and positive 2, and look at that, checks out, okay? We do the same thing with the next one. So to get that from N to M, we're going down 2 and then over 4. So that's negative 2 over positive 4. Which also checks out because that's negative 1/2. And our last slope is Kn. And once again, we're going up 6 and over 3. Both positive since we're moving right and up. And that gives me a slope of 2. Okay. Remember, I don't necessarily need to get parallelogram if I show that these angles are all 90 degrees, okay? I can skip the parallelogram step and go right to rectangle. Now, what I want to do is either state two things. Number one, I'm going to write either that KL is perpendicular to LN, that LN is perpendicular to NM, that MN is perpendicular to KN, and that KN is perpendicular to LK. Okay. So I'm writing the 4 perpendicular statements. If instead of writing all this out, you wanted to just say consecutive sides are perpendicular, feel free to write this instead, okay? We've kind of been putting down congruent and parallel, so we're just kind of filling in the information. But why do we know that this is true? Good, because the slopes are opposite reciprocals, or negative if you want to say that. And finally, because we've shown our work, we've said something about the work, now we can summarize our shape and say that K, L, M, N is a rectangle, good. And because, what do we got? What property we showed? Just good. All angles are right angles. And if you wanted to say like consecutive sides are perpendicular or all 90-degree angles, all those fine things will be okay here. You're just putting down your property. Questions? Nothing too crazy. So easy way to do rectangles is to do the 4 slopes, show this all the sides are perpendicular, consecutive sides are perpendicular, and then therefore we have 90-degree angles. We good? Now, your other option, instead of saying these lines are perpendicular, you could also throw in and just say that angle K equals 90. Angle L equals 90, and then just put down the same thing. Slopes are opposite reciprocals, okay? If it makes more sense to say the angles are 90 degrees, feel free to throw that down instead. Does everyone get the option here? Say they're 90, tell me the lines are perpendicular, make a statement that are consecutive angles or sides are perpendicular or all 90-degree angles, whatever. Just make sure I see slopes opposite reciprocals as a justification somewhere in your proof. All right, let's go down to number 2. This time we're going to use the diagonals for our line. So if we go ahead and graph these 4 points, let's go to graph yours now. And there's our shape. Now, if we're going to use the diagonals, I want us to think about this real quick. What do we really need to show in order to use the diagonals to get to this thing as a rectangle? So what do rectangles have with their diagonals that not all parallelograms do? You could make it simple up if you want. What do we think? They are congruent. Good. So a rectangle has congruent diagonals, but there's a problem. Isosceles trapezoids also have congruent diagonals. So we can't just do this because it could be 2 different shapes. So very good. So they also bisect the angles, but that's really hard to prove on a graph, right? But think about it for a second. What I really could do is kind of like a little leapfrog here, right? If I can make it so that this shape is a parallelogram, then it rules out isosceles trapezoids and only then can be a rectangle with congruent diagonals. So what I really need to do is show this as a parallelogram first if I'm going to use the diagonals, then get them congruent. So what's special about the diagonals of a parallelogram? We talked about this 2 days ago. Because they bisect, okay? In order for them to bisect, they need to have the same good midpoint. So we're going to use midpoint for the first one and distance for the second one. Now, we know the midpoint formula, okay? So if you wanted to, you are more than welcome to do your x2 plus x1 over 2 for your average and your y2 plus y1 over 2. But we also mentioned yesterday, Mr. Brabble mentioned, if you remember, that we can also just draw in the diagonals with a straight edge, okay? And where these 2 diagonals cross is going to give you the midpoint. So you don't even have to do any work. You can just graph this thing and draw these in and just label that point. Please make sure, though, you state the midpoint on your paper. So even if you don't show the work, as long as you put the midpoint of DB and tell me what it is, In this case, it's 6, 6. And you also then said the midpoint of AC is also 6, 6. I'll take it. Because you have the graph and you've shown your work on the graph, it counts. So if you wanted to do the midpoint and do the average, right? 2 plus 10 is 12 over 2. 3 plus 9 is 12 over 2. That's 6 over 6. Same thing for B and D, right? 11 plus 1 is 12 over 2. 6 plus 6, 12 over 2. You're still going to get 6, 6. All right? Now that we know that these are the same, what can we say based on this work? You got it. The diagonals bisect because it's the same midpoint. Okay? Now we got to do the distance of these lines. We got to show that the distances are equal. So now we've got a parallelogram. Okay? So remember, I want to do the distance. Which of these is easiest to do the distance for first, by the way? Which of these is easiest to calculate the distance for? BD, because it's a what type of line? Horizontal. They're both straight lines, by the way. Horizontal, you can just count the number of boxes to get the distance. You don't have to do any work. We just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can just write down 10 because it's 10 units long. Now, we do have to do a little bit of work for AC. So if you want to use the distance formula, you are more than welcome to. We also talked about the fact that you can kind of like create a right triangle using the rise and the run, and then use Pythagorean theorem to do this. Now, we should hopefully already know that the answer's got to be what? 10. So we better get numbers that we plug in the Pythagorean theorem equal 10. And if you count, the rise is 6, and the run is 8. And when you plug 6 squared plus 8 squared equals c squared, or use those points in your distance formula, you're going to end up getting 36 and 64, which make 100. And because we need to get c from c squared, we have to, and the square root of 100 is, and it checks. All right. So now we know the distance of AC is also 10. And because these two distances are equal, what does that tell us? These two lines are also equal or congruent, right? Because they have the same distance, they're equal. Okay? So if distances are equal, they're congruent. Slopes are equal, they're parallel. Midpoints equal, they bisect. Now that we've shown the diagonals are bisected and the diagonals are congruent, does that give us enough information to call it a rectangle? Yes. So we can say A, B, C, D is a rectangle. What property of a rectangle have we shown? Well, specifically, we use the diagonals, right? What did we show about the diagonals? Good. They bisect and equal. And that's enough to make it a rectangle. Now, you might prefer using the diagonals. Great. Keep using it. You might prefer, and I'll come back to this in a second, to just bust out the slopes. Great. Keep using it. Sometimes you might get a question like, for example, on your homework tonight, which is on page 15, where it says, show it's a parallelogram and not a rectangle. This may lead you into using one specific thing for both shapes. Can you double up a formula to do both parallelogram and rectangle? What formula could you double up on? Get out of town with that. You could use the diagonals, but we could also just think about parallelograms, have opposite sides that are parallel, and if we already know the slopes, we should be able to tell whether or not we have right angles because they're not going to be opposite reciprocals. We can do 4 calculations and be able to identify from those 4 slopes both opposite sides parallel and no right angles. Okay, does that make sense? So we don't even have to do any more work. Just do the 4 slopes like we normally do, and we can use it twice. Now, if you did the 4 distances, Christian, to do opposite sides congruent, you just have to show there's not one right angle, and we're good. So just show that one of the angles isn't 90 degrees, and that's enough. Okay? So there's more than one way. But we are going to go back a page here and take a look at page number 14 real quick. Talk about our second shape, which are squares. Okay. Squares are the most amount of work that you're going to have to do because a square is considered to be 2 separate shapes. You have to be 2 different shapes to be technically a square, which are rectangles and rhombuses. So we have to show a property of both a rectangle and a rhombus. Now, there's 2 main ways to do this, okay? If you're going to show a rectangle, what way did we just talk about earlier that we could make this happen? So we need all 90-degree angles, correct? If we have already shown that all the angles are 90 degrees, and we now know that I have right angles, what shape is this also considered besides a rectangle at this point? A rectangle is also not a square. Not all rectangles are squares. It's a parallelogram, which also means that currently the opposite sides are also equal. So in order to be a square, I have to get what for all the sides? I got to show they're all equal. How many sides do I really need to get equal to make them all equal? Just 2. Which ones though? The ones that are intersecting. So if I can show that this side and this side are equal, that forces the other 2 sides to be equal, right? Because their opposite sides are congruent. So I can do all 90-degree angles, okay, and then do 2 adjacent sides congruent, or we can flip that and do all sides congruent with how many right angles? Because if all sides are equal, it's a rhombus, which is a parallelogram. And if as soon as I get one right angle, the opposite one's 90 because they're equal. The one next door to it's 90 because they have to add to 180. They all become 90. So just like when we get 2 sides are equal, if we can show the 2 sides are perpendicular, then all the consecutive ones have to be perpendicular. So all 90 degrees, 2 adjacent sides congruent, or we're going to get all sides congruent and 1 right angle. So your choice. I would have a go-to here. Just decide right now. If you like doing slopes more than you like doing distances, I'd bust those out. And if you like doing Pythagorean theorems and then just doing slopes from there, you can use that. Can you just do all the slopes and all the distances? Absolutely. So feel free to do them all if you want. Okay? You guys want to try this one on your own first? And then we'll work on the summaries? No? Okay, let's do it together then. So go ahead and graph yours first. So pause here. Graph it. All right, we have our shape graph. And remember, you can draw these rise and run lines in, but you don't have to, but feel free. And then you can count. And what do you notice? All the rises for these 2 lines are all 3, right? And you end up with 2 sets of numbers, which are either 3 and 4 or 4 and 3. So guess what the cool thing is? How many times do we have to do the Pythagorean theorem for this shape? Just once. Just once. Okay? We still need to write down the slopes for at least 2 sides, but because I have sets of sides that are 4 and 3, it doesn't matter if you plug 3 squared or 4 squared in, you'll still get 25, which is a distance of 5. What I still want you to do is at least tell me what those distances are. So if you want to write down the distance of AB is 5, BC is 5, CD is 5, and AD is 5. Now, do you guys remember that we would technically, based off of this work, write down AB equals CD equals BC equals, okay? What else could you say because these distances are 5? What property does that justify? Yeah, feel free to just write down like all sides congruent. But what's the reason why this is true? Distant, this is your statement. What's your reason? What calculation did we just do? So the distances are what? Good. Okay? Now, what else do we need to do besides get the distances? How do we get the angles to be 90 again? Okay, how do we know if they're perpendicular or not? Good. Our opposite reciprocals. Good. So I just got to go get the slope. So look at from A to B. What's the rise? What's the run? Rise is, you can use your fingers. 3, run is, and is it positive or negative? Positive or negative? Positive, a good deal. And then we do the slope of the next line, so BC. What should it be before we even do anything else? Should be negative 4/3, right? And if you notice, we go right 3, down 4, so our rise is technically negative 4, and the run is positive 3, and it checks out. Now, we could stop right here. That's enough. We got all equal sides. We got a right angle because we have perpendicular lines. If you would like to just keep writing down for yourself and just keep going around and say, hey, look at that. The slope of CD is also going to be 3/4, and the slope of AD is also going to be negative 4/3. Feel free to do that. What does this work show us again? Opposite reciprocal slopes. And what does that mean? Right? That. Okay, good. So we could say adjacent sides perpendicular. Okay, is that enough now? You could even just write down all right angles instead of adjacent sides perpendicular. Is that enough to say it's a square? Okay, so now we're going to name it A, B, C, D. Dean, A, B, C, D is a... Nice job throwing your voice there, Dean. And because, what property did we show?
All sides are equal and opposite place.
All right, good. Careful perpendicular angles. 90-degree angles, right? Perpendicular lines. Okay, good. All sides congruent and all angles 90 degrees. All right angles. That's it. Okay, here's what I'd like you guys to do real quick. We ready? How about now? Number 2, I'd like you guys to try this one in your group. Before you begin now, I'll go back up so you can see it. Okay? How can you do this the most efficient way possible? You're trying to show that it is a rhombus and not a square. So what calculation would do both of those at the same time? Iftikhar, what do we think? You could pass if you need to. Got it. Christian? Let me ask you this question. How are we going to do a rhombus? Okay, now, what calculation does all sides equal? Can we use the distance to also do not a square? So we don't even have to worry about right angles. We can just do the 4 distances. Oh, actually, we do. Because this is going to do rhombus, and a square is a rhombus. So we still have to show what? Do we have to show all the angles are not 90 degrees? How many angles do we have to show are not 90? Just one. Okay? That means We want to show that two adjacent sides are not perpendicular. So the slopes for two of the sides should not be opposite reciprocals. Okay? So try this one in your group real quick, and then when you guys are done, you can work on your homework. Okay? All right, so you can try this one at home, and then we'll check answers in a second. So we did the four distances, showed the Pythagorean theorem, its distance formula, stated down that those are all equal to 5. We can just count BC and AD, so no work needed to just write 5. We said all sides are congruent because the distances are equal. And this work right here, when we do the slopes, we get negative 4/3, down 4, right 3, and 0, because it's a horizontal line. What does this work tell us? What were we trying to show here? That these lines are what? Not that they're, remember, this is congruent. Now, are they perpendicular, though? Are these lines, are these slopes opposite reciprocals? She's saying they're not perpendicular, right? Because the slopes in this case are not opposite reciprocals. All right, now we've said all sides are equal, which makes it a rhombus, and we've shown that the opposite sides are not perpendicular, so that means it's not a square, okay? So we can say A, B, C, D is a rhombus. Thank you. So we've shown math is not a rhombus. Sally, we should make you not talk every day. This is entertaining, okay? All right? But I'm glad that you're sticking up for morals here. Appreciate it. All sides congruent. Okay? And not a square. Now, two things. You can say because these two lines are not perpendicular, or feel free to say that that angle, B, is not 90 degrees. Okay? Your choice. Got it? Or just say the consecutive sides not perpendicular. Okay, homework tonight. You're finishing up these two questions. Okay? Now, look at question number 2. If you need it to be a parallelogram, if you need it to not be a rectangle, what do we have to show so it's not a rectangle? No 90-degree angles. So what formula do we need? Slope. Can we use slopes to do parallelogram? So we can just use one formula for the whole thing. And the same thing on number 3. If we want to show it's not a rhombus, what do we need? The distances. Can we also use the distances for parallelogram? Yes. And if it's not a square, we just need how many slopes? 2, because we need one angle that's not 90 degrees, okay? So either all slopes, make sense? Get parallelogram and 2 distances, okay? Or vice versa. All right, that's homework tonight. We'll see you lovely people on Monday. Enjoy the weather. It's supposed to be super nice this weekend.